So if we look at lesson number 4, which is the multiplication of polynomials. So this implies that we're not just multiplying two binomials together. We could be multiplying a binomial with a trinomial, or perhaps even two trinomials together. So if we look at the idea of the distributive property in terms of our FOILing, if I have an a plus b times an a plus b, I will get an a squared, an ab, an ab, and a b squared, which when I simplify it, gives me an ab squared plus 2 of the ab's plus a b squared. So I want you to do the next two. Okay, so when I simplify a minus b squared, what do I end up with?
A squared minus 2ab is b squared.
Yep. Did you say minus b squared or plus b squared? Good. And if I take a minus b and I add it, or sorry, I multiply it with a plus b, what do I get?
A squared minus b squared.
Because this time my two middle terms ended up canceling out. An a squared plus an ab minus an ab minus a b squared. So, if I square a binomial operation, what is my pattern? I square the first term, square the last term. How can I use this to get the middle term? So if I go back to the last question that we had before, square the first term, there's my 36a squared. Square the last term, there's my 25b squared. How can I use the 6 and the 5 and the a and the b to get the negative 60ab? Okay, if I multiply them together, I get 30ab. Then times it by 2. Multiply them together. AB times 2, 2AB. Multiply them together. This time I get negative AB times 2, negative 2AB. So that's what this first line. The square of a binomial can be found by squaring the first term, doubling the product of the two terms, and squaring the last term. What do you notice about these two expressions, these two factors?
It's not, it's expanded.
Say that
You
louder.
can have it squared.
I can't have it squared. What do they have in common? They both have A's and B's. What's the difference between them?
One has a subtraction sign.
One's a subtraction sign, one's an addition sign. And what happens to the middle terms in that case?
They're 0.
They're a zero pair. They cancel out. So this one, I could simplify by squaring the last term, and then squaring the first term, squaring the last term, and putting a minus sign between them. We call this a difference of squares. It's called a difference of squares because each of these two numbers are square numbers. These are called perfect square or perfect trinomials. Because if I were to multiply these out using my algebra tiles, I would get a square. If I multiply this out with my algebra tiles, what I get is I get a square like this, and then I get a smaller square, oops, that would be shaded. Because the terms that are here would cancel each other out. Whereas with this one, I would get an A, and then I'd get something that might look like that. I'd end up with a square. And in this case, they'd all be positive. And in the other diagram, the rods would then be negative. Okay. So do class example number 1. The idea being, try to see if you can shortcut it. So what would x plus 7 squared equal if I expand it out? So I'd square the first and I would get x squared. And then multiply the two together, which would give me 7x. Double it, 14x, and then square the last. 49. So if I follow that same patterning, if I square 3x, so 3 times 3, x times x, 3x times negative 1, and double it, negative 6x, square negative 1, positive 1. Okay? Square 2m, 4m squared. Multiply the two together, double it, negative 12mn, and square the last. So things to notice. The last term is always positive, and the middle term corresponds to whatever the sign is here. The next three are a difference of squares because they're the exact same term. One is minus, one is plus. So I multiply the first terms together, multiply the last terms together, and put a minus sign between. So if I do the same thing with E, 5a times 5a, and 3b times 3b, be negative 9b squared. Because if I was to use the distributive property in these three questions, 5 times negative 3b would cancel out 3b times 5a. So those two middle terms cancel out all the time. So in this last one, what would I get? Square. So I want you to work on questions 1, A and B, F and G, H and L. And I think I'll stop there for today. So we're going to continue from lesson number 4 from the other day, multiplication of polynomials. So this is just a series of different examples of solving for or expanding out expressions. So when they use the words expand and simplify, expand means remove the brackets, and simplify would mean collect any like terms. So with this question, with number 2, I can do this two different ways. I could expand out the 2x minus 3 times the x minus 6, simplify that, and then multiply the whole thing by 5. Or I could multiply 5 by this first expression and then multiply that expression by x minus 6. It doesn't matter which way I choose. What I don't do is I don't multiply the 5 by the first expression and by the second. That would be like giving you 3 numbers like that. You could either go 2 times 3, then multiply by 5, 5 times 2, then multiply it by 3, or 5 times 3 and then multiply it by 2. But you wouldn't take the 5 and multiply it by the 2 and the 3. So I'm going to give you guys a minute or two. I want you to see if you can expand and simplify that on your own before I do it with the class. So if I chose to multiply by 5 into this first expression, 10x minus 15 times x minus 6, I would have 10x squared minus 60x minus 15x plus 90. Collect the like terms, and I have a negative 75x plus 90. If instead, if I chose to expand
Well,
these, what?
Wouldn't you put the 5 to the second set of brackets too?
No, it's like what I just explained before. It's not 5 bracket, it's 5 times this bracket times that bracket. You see the difference?
No.
So if I wanted to multiply the 5 by both things inside the bracket, I'd have to have it like that. Or I'd have to have a plus sign between them. And that would tell me to distribute the 5 between.
Oh, so you put the 5 to the first set of brackets.
Right. Because it would be like I was showing before, the 5 times the 2 times the 3. I don't multiply the 5 by both the 2 and the 3. I just multiply it by one of them. Or the other way that I could do this is I could look at the 2x minus 3 times x minus 6 first and leave the 5 on the outside. So then I would get 2x squared minus 12x minus 3x plus 18. And then I would collect like terms. And then I would multiply everything by 5.
Ooh, that
And
makes
I
more.
would still get.
That makes more sense.
Okay, then follow that one. Leave that constant term outside and take care of the 2 binomials first. So with B, the thing to watch out for in B is this 7 plus 3 squared. That means 7p plus 3 times 7p plus 3. And I would encourage you to actually write it out twice so that when you go to expand this, you don't forget about distributing those outside and inside terms, because that tends to be a common mistake made. So we're going to do this by leaving the negative 8 outside of it, and we're going to expand the 2 binomials. So if I take 7p and multiply it by 7p,
49p squared.
7p times 3,
21p.
and then 3 times 7p would be another 21p, and 3 times 3.
9.
Collect the like terms, and I would get 42p plus 9, and then I'd multiply everything by negative 8. So negative 8 times 49 gives me, and negative 8 times 42,
36.
and then negative 8 times 9, so these questions just start to get progressively more complex, but if we follow the same systematic approach, the questions should be able to flow easier. So if I look at A, I'm going to multiply these 2 first, multiply those 2 first, and then subtract them. So if I multiply this together first, what do I notice about these 2 terms? They're the same except one's plus, one's minus. That was my difference of squares. So when I go to multiply this out, I multiply the first terms, I get an x squared. When I do the outside and the insides, I get a negative 5x and a positive 5x, which cancel out, leaving me with 0. So I don't need to put those 2 terms, and then negative 25. Then I'm going to put minus, and I'm going to put a bracket here, because I need to remember to subtract the whole expression. So I get x times x, so I get x squared. And if I look at my outside and my inside, 8 x's and 2 x's would give me 2 times 8?
16.
So instead of writing out all 4 terms, I could simplify that outside, the outside and inside terms together in one step. X squared minus x squared. 0. Then I've got negative 25 minus 10x minus 16. So the negative 10x I would bring out to the front. And negative 25 minus 16. Negative 41. Everything in this second term has to be subtracted. So it'd be like putting a negative in front of each of these, or adding the opposite. With B, to help me, I would write in that 6a minus 5 twice. And then I would multiply everything through. So 9a and 4a. And then these numbers are a little bit larger, so I probably would write them out. 9a times negative 9. And 4 times 4a. And then 4 times negative 9. So I get negative 36. And that makes up one full expression. And then I'm going to subtract the next expression. So I'm subtracting all of this stuff. So 6a times 6a. 6a times negative 5. Yep. And I have 2 of those. And then negative 5 times negative 5.
25.
Yep. Did you say negative 25 or positive 25?
Positive.
And then I can collect my like terms. Negative 81 plus 16 would be negative 65. Right? Negative 60a plus 25. So 36a squared minus 36a squared would be 0. Negative 65 minus negative 60. So if I think of this of adding the opposite, this becomes a plus, negative, plus, negative. So this is the same as negative 65 plus 60, which would leave me with negative 5. And negative 36 plus negative 25. Did you get to later? There are 2 negatives being added together. So negative 36 and negative 25.
Negative 60.
That's as far as we can get. So lesson number 4 is what we're finishing up from this. Well, from this lesson, we're looking at class example number 4 on multiplying polynomials. So when you're multiplying polynomials, you're using the distributive property. So you take what is in one expression and you distribute it, which means you multiply it to everything in the next expression. So if I look at 4a, we are multiplying this expression together. So we're taking the 5x, which is the one factor or one term, and multiplying it by everything inside the other factor or the other expression. So 5x times 3x squared would give me
15x.
And 5x times negative 7x?
Negative 35x squared.
And then 5x times 1.
Plus 5x.
And then we're going to subtract that by the product of these two terms multiplied together. So I'm going to use a set of square brackets to separate that because I have to subtract all of that stuff. So this one again, I use the distributive property. So 4x times 5x, 20x squared. 4x times negative 8, negative 32x. 3x squared times 5x.
32x cubed.
And then 3x squared times negative 8. Okay. What I probably first would want to do with my second expression is probably collect my like terms and write it in descending order. So I start with the highest degree. I take my 15x cubed and I'm going to put it out in front. And then if I combine my 20x squared minus 24x squared. And then minus 32x. Now, when you're subtracting, what's the pattern rule that we can use for subtraction?
Add the opposite.
Add the opposite. So we can change this subtraction to a positive. Then 15x cubed would become a negative. The negative 4x squared would become a positive. And the negative 32x would become a positive. So now I have 15x cubed plus negative 15x cubed, which would equal 0. Negative 35x squared plus 4x squared. And then 5x plus 32x. So the questions just become more time-consuming. They have more steps to them. They're not necessarily harder. They just take more time to go through them. And you need to kind of approach it from a systematic standpoint. You can't necessarily skip a whole bunch of steps in between. So if we look at B, I have three things being multiplied together. So before we left, I talked about when you have three terms being multiplied together. I used the example of 2 times 3 times 4. I can multiply those together in a wide variety of ways. I can go 2 times 3 is 6, times 4 is 24. Or I can go 3 times 4 is 12, times 2 is 3 times 4 is 12, times 2 is 24. Or if I wanted to, I could go 2 times 8 times 3. Or 2 times 4 is 8, times 3 is 24. But the conclusion is that I get 24 each time. So when I go to multiply these together, that 4, I can choose to multiply by this term and then multiply that result by the 3x plus 2. Or I can multiply the 4 by the 3x plus 2 and then multiply that by the 2x minus 7. Or I could multiply these two together first and then multiply the answer by 4. So it doesn't matter which method you take. The thing that you cannot do, and that tends to be something students like to do, is they want to multiply both terms by 4. And that would be like if I had this example and I multiplied the 3 by 2 and the 4 by 2. Would I do that? No. The 2 gets multiplied by the 3, it's gone. I now have a new answer. I multiply that by the 4, and then I have a new answer. So the hint or the clue, the suggestion that I will give you when you have something like this, if ignore the 4 and let's multiply these two together first. So we're going to leave the 4 on the outside and then use my square brackets. So 2x times 3x.
6x squared.
2x times 2.
4x.
And then negative 7 times 3.
Negative 21x.
Negative 7 times 2. And then I'm going to do the same thing with my negative 8. I'm going to leave 8 alone, and I'm going to multiply the x minus 1 and the 3x minus 1. So I'm going to give you a moment to do that first. So what do I get when I multiply the x minus 1 and the 3x minus 1?
Less x.
Okay. So the next, what would you do next? Probably combine the like terms in each bracket. Okay. So 6x squared, 4x minus 21x. Negative x and negative 3x. Now I would multiply the first term, or the first expression, by 4. And when I multiply everything by 4, I get and then when I go to multiply this one, I'm going to treat this as a negative 8. And then that's going to get rid of my need for brackets. Negative 8 times 3x squared will give me a negative 24x squared. Negative 8 times negative 4, I get a positive 32. And negative 8 times 1, I get a negative 8. And then I can collect my like terms. 24x squared minus 24x squared, 0. Negative 68x plus 32. And negative 56 and negative 8. Good. So again, this question is not that much more difficult than the first questions we started off with. It's just more time consuming. There's more steps to it. There are certain things that you could possibly shortcut, but there's not a lot. The only thing that I could see possibly reducing a step is if you could somehow combine these two as you're multiplying this out. But the 4 lines in there would be totally reasonable to see for showing your work on that type of a question. Class example number 5. This is an algebraic type question. It is tricky. It's wordy in what are they asking. So, given that for every value of x, the polynomial x squared plus 20x plus 50 could be written in this form, what are the values of a and b? So we're going to work backwards. We're going to ignore this, and we're going to look at this. What does x plus a squared mean? Well, what does 5 squared mean? 5 times 5. What does 7 squared mean? What does m squared mean? So what would x plus a squared mean? close,
Oh, yeah.
it would mean x plus a times x plus a. I take something and I multiply it by itself. So I have x plus a times x plus a plus b. So now I'm going to expand this out using my distributive property, or that acronym, that FOIL. So x times x, x times a. xa, or if we put it in alphabetical order, ax. A times x, and a times a. So how many ax's do I have? This has to be equivalent to that. So the x squared and the x squared, they match up. This 2ax, 20, has to be equivalent to 20x. So the a would have to be equal to 10. Because 2 times 10 would give me 20 times x. You see that, Raylan? Okay. And then my a squared plus b has to be equal to 50. Well, what does a equal? 10. What's 10 squared? So what's b going to equal? Good. Have I given you any questions to work on from this section already?
Yeah, he gave us one. He gave us one A, B, F, G, H, I, or L.
Okay, but I didn't give you like 2, 3, 4, those ones? Okay. So question number 2, C and D. 3,